Okay, so today we're going to look at graphing quadratics with vertex form. This is not numbered in your notes. It's right after page 8. So you want to look at the worksheet right after page 8. Our objective this morning is to sketch a quadratic function using vertex form. Now, you may recall from the other day that we said that vertex form was given by y equals ax minus h squared plus k, where our vertex is h and k. So remember we said it is the opposite, our vertex is the opposite of h and k, and the same as k. And this will give us our vertex. And a tells us quite a bit of information to tell us opening, how it opens, whether or not it opens up or down, and it tells us the thickness of the graph. So those are some of the things that we can find from A. So knowing whether or not the graph opens upward or downward, whether we know if it's fat, skinny, or regular, and knowing the vertex, we're going to be able to sketch this graph. All right, so again, this is on the page after page 8 in your notes. You should see this little table. And again, this is information that we've already talked about that's just put in a nice table form for you. Okay, so we've already talked about that if A is greater than 1, so if A is positive, it opens upward, meaning that your vertex is going to be a minimum. If A is negative, then it opens downward, meaning that your vertex is going to be a maximum. If the absolute value of A is narrow, it narrows the graph. So our graph is going to be skinnier. If the absolute value of A is less than 1, then our graph is going to be bigger like that. This shifts it right units because remember I said what's inside the parenthesis does the opposite. So it's going to shift it to the right. Whereas when we add h, it shifts it to the left because it does the opposite. Outside the parenthesis, it does exactly what it says. Negative k is going to move it down. Positive k is going to move it up. Okay? Then remember the vertex is hk. The axis of symmetry is written as x equal h. Now in this example, a is the coefficient here. So A is equal to 1. I don't think I put that anywhere. So A is equal to 1. The axis of symmetry is the opposite of this. So since it's negative, it's positive 3. Remember for the vertex, it's opposite, same. So it's going to be 3, 1. Because A is 1, it's positive, it's opening upward. Because A is 1 is just our regular, so we just say it's a normal graph. How is this translated? So remember what we did before. What's inside the parenthesis does the opposite. So that means it's going to move 3 to the right and up 1. The domain for all quadratics is negative infinity to infinity. And then remember, because it's opening upward, meaning that it looks sort of like this value, this y value, which is 1, this y value is going to be a minimum value, so the range is going to be all numbers greater than or equal to 1. So from this, we can sketch the graph. We see that it has a vertex at 3, 1, 2, 3, 1. So we went over 3, up 1, and that because A is positive, it's opening upward, and it's a regular graph. Okay? Let's try this. This time I did list A. A is negative 2. So remember, A is this coefficient. So A is negative 2. Our axis of symmetry, we do the opposite here. So our axis of symmetry is negative 2. Our vertex is the opposite, same. So our vertex is going to be negative 2, negative 3. I take the opposite of this number and keep this number the same. Because A is negative, it's opening downward. Because the absolute value of A, so the absolute value of -2 is 2, and if the absolute value is greater than 1, then it's going to be skinnier. How is it translated? Remember, it does the opposite in the parenthesis. It tells us to do the opposite, so it's going to move left 2 and down 3. The domain should be a no-brainer at this time, and our range, because this is opening downward at -2, -3, then it looks like this. So then the range, this is a maximum value. So -3 is going to be the maximum. So it's going to be less than or equal to -3. And the graph will look like this. Notice the vertex is at -2, -3. Okay? Alrighty, so once again, A here is 1/2. Okay? Which means it's positive and the absolute value is less than 1. The axis of symmetry, we do the opposite. We do the opposite of that, so x is -1. Because this is like saying there's a 0 out here, my vertex then is going to be -1, 0. Because A is positive, it's opening upward, and because the absolute value of A is less than 1, it's going to be wider than normal. So how has it moved? It moved left, because it does the opposite of what's inside. It moved left 1. So our domain, all reals, please don't miss that on the test. And the range, again, because it's opening upward, where is it? -1, 0. It's opening upward. I didn't draw it right. But so the minimum value is going to be 0. So that means the range are all values greater than or equal to 0. And it looks like this. And once again, our vertex is at x is -1 and y is 0. Okie dokie? All right. Let's try some of the matching at the bottom of the next page. So again, that page isn't numbered, but if you just flip it over quickly, you'll see 6 matching problems. We're going to do the first 3. Okay? So in order to do these matching problems, we have to know some things about the graph. The first thing we need to know, what is its vertex? So the vertex here is, this is 1, 2, 3, 1. So my vertex is 3, 1. My A, I don't know A, but I know that it is positive. Okay? And I would say that that's about a regular graph. It does, or if it's not regular, it's skinnier. So I would say A is either 1 or greater than 1, because this looks skinnier to me compared to this one, where this one looks fatter. But this looks skinny to me. So we know that A has to be 1 or greater. So what we need to find, and we know A is positive. So that means our equation is going to look something like A, where A is a positive number, x. Now remember, when we're putting it back into vertex form, I have to do the opposite. So this becomes x -3 and plus 1. Because remember, this is h and this is k. So this becomes plus 1. Okay? So I am looking down at the bottom to find one that looks similar to that. C is similar. Do I see another one with -3 and plus 1? F, but F has a negative A. -3 and plus 1. So it seems like C would be the best match. So C was y equals 2, x -3 squared plus 1. And you may say, well, how did you get 2? Well, it was actually just the process of elimination. I knew A had to be positive, and I knew the vertex was 3, 1. And the only one that meets that criteria is C and F. But F has a negative A, so that disqualified it. Okay? Let's do the next one. Let's start by finding the vertex. So the vertex here is 1, 2, 3, and 1. So A, in this case, A is negative. And A, again, is either going to be greater than 1 or greater, because it looks either skinny or normal. Okay? So then I know my equation is going to be A, where A is some negative number. So let's say negative A. This time it would be X, it's still X minus 3, because we take the opposite of this one plus 1. Well, we've already said that the only one, well, actually A has the same vertex of 3, 1, and it's negative. I would say that it's A rather than F because it's skinnier. So F, because it's 1/4, is going to make it a fatter graph. So I would say the answer for that one is A. And again, you can graph them on your calculator to check it. So I would say this is y equals negative 2 x minus 3 squared plus 1. And again, I'm doing this by process of elimination. I know that the vertex is 3, 1. I know that it's upside down. And I know that it is either skinnier or regular. So then that means that A, the absolute value of A, has to be greater than 1. And for the last one, do all of them have the same vertex? 1, 2, 3? Well, that made it very convenient. Again, my vertex is 3, 1. I know it's negative. And because this is wider than a normal graph, I'm going to say that A, the absolute value of A, is less than 1, meaning it's a fraction. And we've already said that the only one that meets that criteria is F, because F is negative 1/4 x minus 3 squared plus 1. So this is the vertex. It's negative, means it's going downward. We see it's going downward, and 1/4 tells us it's going to be a little fatter. Okay? So what I need you to do is I need you to complete problems 4 through 9. The rest of the problems on these page 8 and the back of page 8. I'm sorry, the page after page 8. Let's say 8A and 8B. I need you to finish all of those. And then I want you to, when you are finished, I want you to use Desmos to check your answers. So you can graph these on Desmos, or you can use the graphing calculator. You can graph them and see if you get the same answer. Okie dokie? Alrighty, then your homework, you have no homework from this section, but you do have an exit ticket. So you want to do exit ticket day 4A. So you want to do that exit ticket. Okay? Have an amazing day. Oh, and you do have another video to watch. You still have to watch the video on going from Vertex to standard form. So watch the second video as well. Have a great day.